Welcome back, ladies and gentlemen, to the July AMA. In tonight's update, I'm going to be giving you an update on where we are with the airframe, the GT50 engine program. I'm going to give you a live production update from around DC1 here, so you can see what's going on right now at the development center. We're going to talk about the avionics and the electrical system development, and then I'll talk about the factory development and our approval programs, both for HC and HX. These were one of the first tools that we produced before we nailed the vacuum integrity on the parts. And what you can see here, that in certain areas, there's areas where we're slightly dry, there's areas where the surface finish isn't perfect, and there's areas where the infusion strategy hasn't been quite right. And those areas would mean that these molds were rejects. Over the course of the last 3 or 4 weeks, we've been doing an awful lot of development work to move this process on so that we can reliably infuse these patterns and molds. Now, in order to do that, we actually made a further test pattern here off the same, a test mold here off the same pattern, but this time, rather than using carbon cloth, we've used exactly the same cloth topology, but in glass. And the reason for that is glass is, of course, clear. We can see through it, so it makes it very, very easy to inspect and verify that the infusion process has worked properly. Now, using this process and using a slightly improved infusion strategy, we've now been able to repeatably produce infused, high integrity, high quality molds at room temperature, which give us the ability to reproduce these things quickly and inexpensively and scale up for production. So really, really pleased with the work that Dave and Tim have been doing at DC2 and down at Saltash. This has really drawn a period of about 12 months worth of work to a close and sets us up really nicely for putting these things into production. So well done, guys. Really pleased with what we've done here. Let's go and have a look at glazing for a second. So this is the rear part of the wraparound section of the windshield, and what we've done here is we've applied the same sort of mirror finishing process to the top of this tool. So this has had a layer of paste, some hand finishing, and then a top coat and polish. We've applied the same finishing process to this that we're now applying to all of the patterns that make the composite parts, so that when the composite parts come out, they're essentially immediately ready for paint. And what you can find here is that the optical quality of these parts is now really, really good. All of the witness lines have gone. The only minor defects that you can see in this panel are simply because the environment where this was formed wasn't quite up to clean room standards, which it needs to be to form optical panels. Now, polycarbonate is a much more difficult material to form. This is a part that we also made today off the same tool, but using a different forming process. This was drape formed rather than vacuum formed. And what we've shown with this is that, sadly, there's no escaping the heated aluminium tools for this. We're going to need to go the full hog to get the optical quality right for these parts for the flying prototype. So we're just going to have to bite the bullet on that one, I'm afraid. But what this does show is, in terms of forming it, we're spot on. We just need a slightly better tool finish and a heated tool to be able to get the optical quality to where it needs to be, particularly for that front windshield. Now, in the last update, we introduced the current state of build on the GT50 engine. A lot of these early components now have been through detailed analysis. We're doing the last elements of the structural optimization on this to clear the engine for prototype component release. The compressor is pretty much there now in terms of the optimization of the blade frequencies and the last couple of details with the secondary air system. A lot of the details in the shaft are almost there as well, and so we expect a lot of these components to be released in the next few weeks. And then, of course, the big effort over the last couple of weeks has been the turbine blades. So the way the process works is essentially the first thing that we produce is a wax turbine blade. We've actually made this one out of a stereolithography plastic resin for the purposes of prototyping, but we tool this in aluminium and then injection mold wax versions of the turbine blades in production. From that, we then assemble a range of these things on a wax sprue inside a casting vessel. This can then be used to shell or block mold the blades, and then we burn out the investments, and then in the place of this we can then pour in metal to create your super alloy turbine blade. And all of that process development has been going on over the course of the last few weeks with various partners that we're working with, and that applies equally well to the power turbine blades as well. So there's the investment you start with, and there's the super alloy blade that you finish with. I should, just to be clear, iterate, these ones aren't cast. This is what we're going to be casting over the course of the next few days. Seeing several transmissions at the moment to enable us to get a pair of these transmissions on the test bench and running through an extended life test to clear them for flight testing. What we've got on here at the moment is another one of the Planet gears. So these are currently being hard machined, so that is aerospace grade gear steel. It's been through an aerospace approved hardening process. All of the traceability and all of the measurement that feeds into this process has been done and locked down, and very shortly we'll have a full set of those for 2 HX50 main rotor transmissions. So pleased with how that's coming on. One of the things that you'll notice shortly, or I'll show you shortly, is we've actually had to procure a second 5-axis just to keep up with the demand of producing gear and bearing components. On the 3-axis at the moment, we've got the second HX50 main rotor gearbox casing about to be produced. So this block of aluminium at the moment will shortly be turned into the lower housing from a main rotor gearbox. So Josh, I don't know if you just want to point at that one over there so people can see. The lower half of that gearbox is what we're producing over here at the moment. And then earlier in the week, we've been producing the first of the brake calipers for the HX50 wheeled undercarriage, in addition to the brake discs, in addition to the brake calipers. And the second job you can see on the bed of the 3-axis over here is actually the opposite hand of that caliper. So lots and lots of components being manufactured at the moment. Over here on the lathe, we've also got further engine transmission gearbox. So this is the input pinion that sits at the top of the speed reduction gearbox, and this is one of the three sets that we're producing for long-term testing. So 1 for the demonstrator and 2 for long-term testing, where we're going to run these for 5,000 hours. And then if we go over to the new lathe, this machine's been bought specifically to keep up with gear and bearing demand. What you can see on the floor here actually is this is the first HX50 wheeled undercarriage. So it doesn't look like much yet. That material landed today, so over the course of the next couple of weeks we'll be making the first set of undercarriage for the HX50. On the second lathe that we've got over here, we're currently producing the gear. This is the first stage wheel for the speed reduction gearbox. So integral curvic couplings, all the lightning holes in there, and that's now literally just waiting for its teeth on the 5-axis. So from concept through to reality. Here is the very first batch of sprag clutch housings for the back end of the GT50 engine. So the first 3 for the first 3 build transmissions, and then here we've got the sprag clutch output shaft that connects with that device down there through the sprag clutch itself. First 3 of those there, again from concept to reality. And something a little bit different over here is on the lathe at the moment. We're currently producing the first HX50 wheel hubs in there. So the first set of alloy rims, and that'll get finished over the course of the next day or so. Given the amount of machines that we're now operating in parallel, we've also recently invested in some offline tool setting equipment. So this allows us to fit tools into tool holders and interchange them between the machines without taking a machine out of production, as very shortly we're going to be limited by production capacity on a lot of these machines. So that came in over the course of the last couple of weeks as well. And then again, this is the second 5-axis that we've just installed. This came in 2 weeks ago now. It's just been calibrated, and Mark's currently got this one working on, again, more high-speed gears for the GT50 transmission. So that's in essence what we're up to at the moment in terms of machining the mechanical components. Let's go and have a look at what Dave's been up to down at DC2 on the composite side. We've also been doing some work on the very first HX50 door. So this is the first co-pilot door that we've produced. Again, ignore these components here, they're unfinished bits of trimming. This allows us to essentially prove out the hinge strategy, the ability to take the doors on and off, the ability to seal, adequately verify the stiffness of the doors, and a bunch of other practical trials that allow us to verify the quality of what we're producing for the aircraft fuselage as well. And then one other thing that I just wanted to mention on in the context of some of the things that have been going on in the press recently is the suitability of carbon fibre as a whole as a material for aircraft. Now, carbon is an amazing material. It's not good for everything, but it's really, really good for aircraft. If you take this portion of the tail boom here, okay, what I've got here is a section of the laminate. It's ludicrously light, and the way it's manufactured is this particular laminate is literally just a single ply of carbon, a honeycomb core, and then another single piece of carbon. It's really, really light, and to give you an idea of its strength and stiffness, you can jump up and down on this and it can take a full person's weight, and that's from something that allows us to make that tail boom for just over 20 kilos all in. And so carbon's an amazing material when it's used correctly. It's extremely stiff, it's extremely strong, and in terms of fatigue, because it's essentially made up of lots of individual load paths within the material, bathed in a resin that passes the load from one fibre to another, it's full of natural crack stoppers, which means that from the point of view of a helicopter where the thing is permanently being shaken by the main rotor, it's very difficult for cracks to propagate through carbon fibre. So for our application, it is an incredible material. It's difficult, as we've shown, to make good composite parts, but once you can do it, you can make the stiffest, strongest, and most damage tolerant parts that you can with any material that's available for making aircraft. So for our application, it is an absolute no-brainer that it's the right material to use. And then the other thing, of course, is, as you've seen from our trials on the crash-worthy seats, it has an incredible ability to absorb energy. So in terms of absorbing the energy from a stroking seat, or in terms of developing a crash structure on the bottom of the aircraft that absorbs energy as well, carbon is definitely the right choice if you're making lightweight flying structures. So rest assured, carbon is not a villain material. It has amazing properties if you know how to use it properly. And one of the final things that it does that's really important for a helicopter is that the main rotor is constantly shaking on the top of the fuselage, and we have to be able to tune this structure so it doesn't want to vibrate at those specific frequencies. And carbon, because we can align the fibers in every direction, well, any direction we want to, we can tune those modes of vibration with far more precision and ease than you could with an isotropic metal material. So again, carbon is amazing for what we're doing with it with HX50.